Greetings to you all. Sanibonani, Dumelan. So today we'll be doing the geometric series. Do the sigma notation. So let us start.
Okay, good people, we will do the geometric series and sigma notation. Like we explained when we're doing the arithmetic series, this is what this symbol represents sum and is a capital letter S in Greek alphabet, which implies that we are dealing with some of the terms of the sequence. Okay, so this will be what this will be. You know, this is the general term, for a geometric sequence. Okay, so this will be find the sum of the terms that are given by this general term, where k equals to 1 will be the first term to be substituted and n will be the last term to be substituted on this general term. Okay, this one is the sum of what the formula for the sum of what of the geometric sequence. Now example 1, calculating the sum. So what is the first thing that we need to do here? We need to find what? We need to find a series. Okay, now from our series we're gonna say, what do we have? We need to have, gonna have 3 into 2, and the first number to be substituted is 1 there. The first number to be substituted is gonna be 1. 1 minus 1, close the bracket, plus the second term is going to be 3 times 2 minus 1, close the bracket, and then this is going to be what? 3 into 2, and then term number 3 is going 3 minus 1, and I close the bracket there, plus etc, just like that. Okay, now this is going to be 3 into 2 exponent 1 minus 1, which becomes 0. This is 1, 3 times 1 is 3. Now we get 3, plus we put 2 there, we now get 6, plus we put 3 there, now we have what? We've got 12, plus etc. Okay, now from here we know that the first term is what? The first term, we now have the first term. The first term is a. Our a is going to be equal to, our a is equal to 3. Okay, our a is equal to 3. Okay, now we need to get what? The constant ratio. Now with the ratio we're gonna say T2 divided by T1, that is going to be 6 divided by 3. We get what? We get 2 there. Now let us confirm our ratio. You see R also is equal to T3 over T2, that will be 12 divided by 6. The answer is 2. Now we are confident that the ratio is 2. Okay, now how do we find the number of terms? Because here for sum we need to calculate the number of terms. Now how do we get the number of terms? The number of terms we said is equal to the last one to be substituted minus the first one to be substituted plus 1. That will be the last one to be substituted. The last one to be substituted, that will be 19. The number will be 19 minus the first one is 1 plus 1. So we are going to have 19 terms. Okay, so now let us now calculate the sum. We go back to the formula for sum. That will be Sn is equal to A into Rn minus 1 over r minus 1. So the sum of the first 19 terms is going to be equal to a is 3 into r here is 2, n is 19 minus 1 all over r is 2 minus 1. That will be sorry for that. So I substitute r there, 19 there for n, and r there is 2 minus 1. So we punch all this in our calculator. That will be 3 into 2 to exponent 19 minus 1 over 2 minus 1. That will be 1,572,861. 1,572,861. Okay, so that will be the sum of the first 19 terms that is given by this what to call general term there. So we first need to find the series. Okay, how the series goes, and we get what? We find our a and we find our r, we find our n. How do you find our n? By doing what? By saying the last number to be substituted minus the first number to be substituted plus 1, and we come to this formula here. Now let us look into example 2. Let us look into example 2. Finding up to where must be added. Okay, so in this case we're told that the sum of the terms that are given by these general terms starting from Q1 to M is equal to 65. So this is what? This is Sn. This one, it's sum. This is Sn. Okay, we now have Sn. So we need to find A. We also need to find R. Okay, in that case we will be able to find N. Okay, which is M. Now we're gonna say for the first one that will be 5 into 3. The first term to be substituted, it's 1 minus 1. We close there, plus 5 into 3, 2 minus 1. We close there, plus 5 into 3, 3 minus 1, and we close there, plus, like that. So this is going to be 0, 0. 3 to exponent 0 is 1. 5 times 1 is 5. 5 plus 5 times 3. This is going to be 15, this one. 15, this one. And then here, what are we going to get? We're going to have 5 into 3 to the exponent 2. 45. 45 plus etc. etc. So A, which is the first term, is 5. We need to find what? R. Okay, so R is equal to T2 over T1, which is equal to 15 over 5, which is equal to 3. Let us confirm the ratio. R is equal to T3 over T2. That will be 45 over 15. The answer is still 3. The answer is still 3. Now the constant ratio is 3. But we also know what? We also know that Sn is equal to what? Sn is equal to 65, because we are told that the sum of the general terms that are given by this general term is equal to 65. Okay, so we come to our formula for calculating the sum. That will be a into r to the exponent n minus 1 over r minus 1. So we know there we've got what? We've got 65, which is equal to a is 5 into 3, we're looking for n, minus 1 all over 3 minus 1. Okay, so that will be what? That will be 65 5 to 3 to exponent n. When you multiply this one and you say 5 times that, is going to be minus 5. Okay, all over 3 minus 1 is 2. And then now you do what? You cross multiply. 65 times 2, 130. So 130 is equal to 5 into 3 to the exponent n minus 5. You transpose 5 to the other side. 130 plus 5 is equal to 5 into 3 to the exponent n, and then this is going to be 135. 5 into 3 to the exponent n. We divide both sides by 5. 5, this takes that, and 35 divided by 5, this is 27. Okay, so this gives us 27, which is equal to 3 to the exponent n. Okay, so we can also say, okay, 27 equals to, and we look for the prime factors of 27, that is 3 to the exponent 3. Okay, that will be 3 to the exponent 3, and then 3 to the exponent n. So when the bases are the same, we can simply equate the exponent. So n is going to be equal to 3. So that will be our m. Therefore m must be equal to 3. We must add up to 3 terms for us to get what? For us to get that sum, which is 65. Okay, so another way of getting from here, another way we can get that n, because we have what? We've got 27 is equal to 3 to the exponent n. Okay, we can still use the logs. We're gonna say log of number base of 3 is equal to the exponent. So we're gonna say log of what? 27 base 3 is equal to n. So n is going to be equal to, we say this is base 3 log of 27. So the answer is still what? The answer is still 3. So n is equal to 3, and you see therefore m is going to be equal to 3. Okay, that will be the end of my lesson for what? For the geometric series and sigma notation. I hope you enjoyed. Thank you.